Okay, welcome back. So, we will continue our discussion from the previous lecture. If you remember, in the previous module, we were talking about landfills. We were talking about especially towards most of the module content for the previous video is on landfill gas. So, we kind of wrapped that part in the previous video. So, we will continue our discussion, and today if you remember from all the discussion we had with respect to landfill, especially when we were talking about landfill, trying to make the landfill more as a treatment unit rather than a containment unit. So, there is a difference. The typical landfill, even in the engineered landfill, of course, the landfill that as we know of in India, if you go to say Kolkata or Madras or most of these dump sites, like in Delhi there are 3 big dump sites. So, those dump sites are not landfill. I think that must be very, very clear in your head by this time. That is not landfill that we call landfill from a technical point of view. That is a dump site where we are just putting the waste. We have some maybe little bit of control here and there, but essentially there is no leachate collection system, there is no gas collection system, and there have been in some of those sites people have tried to collect the gas, but that's again it's not really designed as an engineered landfill. So, there is some stopgap measurements, some retrofit measurements, retrofit arrangements have been done. So, but as per MSW management rules 2016, the way we define engineered landfill, they are not. There are some engineered landfills out there in the country. Coimbatore built one, Surat had one for the long time, and they had some issues of disposal of garbage where the landfill was built but did not get garbage for a long period of time. That issue was there. But in general, but even those landfills, it's essentially what you have. You have the liner at the bottom, you have liner at the side slope, and when you put all the garbage in, you put a top cover on top. So, what you have is a huge polythene bag. You can think about like a huge polythene bag, and this polythene bag is carrying all this garbage. And that is why when I said earlier in one of the very initial video that even after 20-25 years we could read newspaper coming out of those landfill, so that they had not degraded. So, that is why this concept of this bioreactor came in picture. So, today we will talk about this concept of bioreactor landfill. And so, what is a bioreactor landfill? Bioreactor landfill is essentially where you are trying to operate the landfill in a fashion to accelerate the decomposition of the solid waste. So, rather than keeping it as a dry tomb, which is essentially a you can say that that's more as a containment system, we are trying to use this landfill as a treatment system. So, you are trying to operate this, again we are talking about the sanitary landfill, the same engineered landfill, but we are trying to operate in a fashion to accelerate the decomposition of the solid waste. So, what happens in a landfill? It's mostly anaerobic. Initially there could be some aerobic, but mostly it's an anaerobic conditions. So, we have an anaerobic bacteria which is going to degrade the waste. We said that earlier in the several videos as well, the bacteria loves moisture, and if it's a very good distribution of moisture in the waste, that's very similar concept as what you will see in a wastewater treatment plant. So, wastewater treatment plant, the basic concept is same as what we are talking about in this bioreactor landfill. We are trying to make this conditions suitable for these bacteria, set of bacteria, so that they can eat those organic matter, which is essentially the waste, and when they eat those organic matter, in the process they degrade them and they produce methane gas. So, we can capture that methane gas for energy and other purposes, and you saw those gas generation curves. So, where we can, so in the operating it as a bioreactor landfill, we can reduce the half life. So, with the waste will degrade much faster, and when it degrades much faster, you will have the amount of gas produced in a shorter period of time. So, you can have a portable genset, you can do some electricity generation and all that. So, it's operated to accelerate the decomposition. So, that's the key word here, to accelerate the decomposition. So, because the decomposition will take place, but in a dry tomb landfill it takes place over a very long period of time. Here we are trying to make it in a much faster way. So, how we do it? We do it by getting recirculating leachate to the landfill. So, what I said that we have to improve the moisture content inside the landfill. So, since we have to improve the moisture content inside the landfill, no regulation, if you look at any regulatory body, I don't think any regulatory body around the world will allow us to put clean water inside the landfill, because once the water goes inside the landfill, it becomes leachate. So you will find that where the clean water, groundwater or surface water will be allowed to be put in the landfill, because essentially what we want to increase the moisture content. So to increase the moisture content, we need to put some water, we need to put some liquid in there. So since leachate is produced at the landfill site itself, so we have the leachate production system, leachate collection system. So all those pipes that I showed you, so we have this leachate being collected. So the thought is, why don't we just take these leachates, which is already there, and then we recirculate it back into the landfill. So that's what we do here is it says that primarily accomplished by getting recirculating leachate to the landfill. It says primarily because that's that's the main way of doing it. But there would be other way too. You can inject sludge. You can sludge is usually have, say, if you have to dispose wastewater sludge has very high moisture content, so that could be disposed. So that will help in increasing the moisture content and make the waste degrade faster. So those things are done. We have been working in our research program. We have done a lot of work on bioreactor research in the past, and also right now mostly from the lab scale. In the Indian contest, we are mostly working in the lab scale. We would like to do it a pilot scale or a field scale, but we haven't got the chance to do it. But there is a lot of work needs to be done, because when you're trying to operate this landfill as a bioreactor landfill, you have to be careful in terms of the hydrostatic pressure being built up inside the landfill. So there is those things are there. There are a lot of work from the hydraulic side needs to be done. There are a lot of work from landfill gas collection system, how to augment the collection system. Now you have a more gas being produced so that you can capture those gas, not let the gas escape out as a fugitive emissions. Then there is a lot of work needs to be done in terms of the leachate recirculation system, how to design this leachate recirculation system so the moisture is evenly distributed, and then how to measure the moisture content inside the landfill so that we know that yes, the moisture is really traveling. So how to make sure the design of leachate recirculation system is actually working on field. So those a lot of research or applied research essentially needs to be done. And as an engineer, it's our role. As an engineer, our role is to apply the science. Of course, science is very important, but application is more important in my view. If we have to, unless you apply that for human good, then there is no point of all those sciencey papers being published from the lab and with no application. Gives a good CV, gives a good thesis, but nothing changes on ground. So coming to this, so this is a concept of the bioreactor landfill. And then, so how we operate, so that was just to give you an kind of quick overview of the bioreactor landfill. What is the concept? We will not cover too much detail about the bioreactor landfill. That could be itself a 4-week course on an NPTEL program, maybe sometimes later in few years when this technology gets popular in India, if it does get popular in India. But we'll talk about that. But right now we'll just focus mostly on in this video. Right now we are focusing in general landfills. So we'll talk about now how the landfills are operated. So far, if you remember, we talked about landfill how the liner system, we talked about the leachate collection system, we talked about the gas collection system, introduced you to the bioreactor landfill concept. Now we'll talk about, so once the landfill is being built, how it is going to be operated, the economic side of it, the management side of it. So the operational issues, management issues that we are going to cover in next few slides. So how the landfills are operated, first of all, the trucks has to come in. If you go on, again, I encourage you to go on YouTube and other places, or you can go to certain landfill websites and you can see several videos. I do have several, but it's difficult for me to incorporate everything in like a 30-minute video slots that we have. But you can find it on YouTube. There are lots of videos which will say how the typical landfill is operated. You will see several videos from around the world. So essentially, you will have it. So trucks comes in and they will come on a scale. The truck will come in on a scale, on the scale and a weight. So you will have the truck being weighed, and truck is also weighed on the way out. So you have the truck being weighed into way in and also from the way out. And the difference of the weight actually gives the weight of the garbage, isn't it? So you have initially the truck coming in, so it's the weight of truck plus weight of garbage in there. Then it goes to the landfill site where the waste is being decomposed. It drops off the layer of the garbage. So what is left now? And then when it comes out, again your weight. So it's a so now it's the empty truck. So empty truck, the first weight, which was the weight of empty truck plus the garbage minus weight of empty truck, that gives you the weight of garbage. So that's how you know how much garbage got disposed into the landfill on that particular day, and that's based on that only you pay the tipping fee and other fee that you charge. So then the tipping fee is charged. Tipping fee is the fee per unit of weight that say municipality have to pay. So say if I own a landfill, if I am owning a landfill, or if within a municipality, even if the municipality owns a landfill, it's the different division. So landfill division is there which owns the landfill. Then you have the waste collection division which does the collection part. So this waste collection division, as part of its disposal, at least on its books, there may not be transfer of money, but at least on the books it will show that per ton there is a charge of say $25, $30. In Delhi it was 1500 rupees per ton. So that's the tipping fee for the waste to energy plant, that the Jindal waste to energy plant, that they told us 15 to 1600 rupees per ton. That's what they get. So here like a tipping fee is a fee for disposing of the garbage in the landfill facility, or even to the waste to energy facility, compost facility, anaerobic digester facility. So you need to charge money. Unless you charge the money, how will you run the? So if to run your facility you need to get money. So this is the revenue source. You charge money, and this money gets charged to residents ultimately. So if I and you, as part of the Municipal Solid Waste Management Rules 2016, it says that user has to pay a fee designated for waste as a waste disposal fee. And right now at some places it is, most of the places it is part of the property tax, but if it's a separate fee, that fee will the municipality is used to pay the tipping fee that it has to pay in terms of a waste disposal. So it's a tipping fee is usually normally based on the weight, so that's how it is charged. $1.25 per ton. It's a typical, like it's a on the lower side, especially for the North American standard. If you go to Canada, it's much higher. In US also it depends. It's depending on the states, it keeps on changing. So they were the truck truck will take the waste and deposit the waste at the working phase. So now we are here, we are using a term working phase. Now what is this working phase? So you have the landfill, as I said earlier, typically the landfill site is selected for the period of 30, 40, 50, sometimes even up to 100 years. So you will have several acres of land. So you don't want to use those several acres of land and develop the whole area at one time. What you do is you divide it into different cells. So there are different cells which is there, and then each cell has few acres, and so where the waste is being disposed at that particular time, that is known as the working phase. So if it's a cell 1, in that cell 1 area where the waste is will be taken, so there will be approach road, you go there and you dump the garbage. So that area is called the working phase of the landfill. So that's what we are talking about. That's where the work is going on right now. And then we have the landfill operators which will compact the garbage. Garbage compaction, why it is done, we already talked about it. The waste is covered at the end of every day. So usually by soil, but possibly by other materials, other waste materials as well. Anything which is inert, which doesn't have a smell, that is used for any industrial waste or wood chips, talc, those kind of material is used there. Soil is, if the soil is available, that is used as well. And so that's called daily cover. And why it is done is because you don't want to attract birds and all those that control some smell for the neighborhood. So that's the reason why these things are done. So you have then landfill has to be, once you have we start, say you are working on cell 1, and which is 2 acres or 3 acres, then you put garbage in there based on what is the waste generation rate for your particular town, say after 5 years or 10 years, or what your cell A is full now. When we say cell A is full, that means it has reached the height which is the permitted height. So based on, you have to take the permit. So it's the based on the permit document, you were told that you can go say up to 20 feet, 30 feet, 40 feet, or higher or lower depending on the soil profile, the soil bearing capacity, and the other factors around the site. So which we discussed in the past as well. So it's so you have a certain height, so you reach the certain height, then you put the landfill, you put the liner cover on top. So then it's called the landfill is closed. So once the landfill is closed, so it's usually the say cell 1 is closed. So and then we close it according to the regulation. So when we say regulation, you put the top cover, then you put some soil on top, you put some vegetation on top. So there is a cap is designed. So landfill cap, it's called landfill cap because you're putting a cap on the landfill. So this engineered cap must be constructed. So it's there is a way to do it, and then again your rules will tell you how to do it. The purpose of the cap is to design to keep the rainwater out and gases in. So cap, we don't want rainwater to percolate to the garbage, because if the rainwater touches garbage, it becomes leachate and your leachate volume goes up. So you put the cap in such a way so the rainwater intrusion is less, as minimum as possible, and then no gas getting released from the landfill side. So gas emissions is also controlled. So then landfill has to be maintained, and so because the landfill, as the waste is degrading, it will produce leachate, it will produce gas. So to have and it produces for over a long period of time, especially in a dry tomb landfill, as we explained earlier. So we have a post closure period of 30 years at least. So that's what the regulation wants, at least 30 years. Some of these landfills, which is since this line landfill concept globally came in early 80s. So now we have some landfills which were built from early to mid 80s are already exceeded 30 years. But still those landfills, since they are producing some gas, they are producing some leachate, we are still monitoring them. So it's we haven't stopped monitoring them. So when I say we, I'm talking about the big waste management fraternity around the globe. So it's not me and my students who are monitoring it. It's the different companies on the different landfill sites. So it is still being monitored, because it produces some land. That's why the concept of this bioreactor landfill. What happened, say early 2000s, late 90s, early 2000, after having operating this engineered landfill for 10-15 years, people started realizing that waste is not really degrading very fast. So this waste will remain for a longer period of time, even after post-closure care period, which is of 30 years. So why not we try to operate it in a way so that it becomes, the reaction is faster. So that's the whole concept behind a bioreactor landfill. So it's we have to do this post-closure care, which is 30 years. So it's a costly, isn't it? You have to observe that site over a period of 30 years. So there will be few people who are employed. They will be going in, collecting leachate sample, collecting gas samples, collecting groundwater monitoring samples, surface water samples if needed. So there is a lot of things that has gone through, and of course it's a job for the consulting firm. You can give a contract to the consulting firm, they will do everything for you. But still, when I say as a landfill manager, we can do that, but the problem is it's a money. You have too much money to spend on that. So the tipping fee that you charge is should take into account that money that you need for 30 years for the post-closure care, and sometimes even beyond 30 years. So those things, so the tipping fee calculation has those things built in as well. So the landfill has to accrue money. So landfill has to accrue money to pay for closure and post-closure during the life of the landfill. So that's kind of very important part of a landfill management and operation. Then groundwater monitoring, I mentioned that using that sketch, that if you had along the periphery of the landfill, so if you are looking at the landfill boundary, so this is from the top. If you look at the plan view of a landfill, so this is your landfill, which is a plan view. Of course, things will go something like this, and then you will have the bottom part. But if this is the plan view of the landfill, just the top part, and then what we do is the whole landfill boundary, this will go kind of out of this screen here, but all along this we put several wells. We put several wells, and then we will monitor the groundwater from these wells. So the reason for doing that is to find out if there is any contamination happening from the liner system. If the leachate is passing through the liner system and going and contaminating the groundwater. Sometimes even with this changing the hydrogeology of the landfill site, because once you put the liner system in here, you are cutting off the oxygen supply, and since the oxygen supply is cut off, the biogeochemistry inside the subsurface changes, and that also leads to some problem in terms of groundwater. It may not be contamination coming from the landfill, but the landfill created conditions such as so that some of the contaminant which was non-leachable earlier is becoming leachable now. A big example that I have seen in the research projects that I have been involved with is we have seen the iron, especially since many parts of the world has very iron content, like iron content is very high in the soil, and as you know, iron typically exists in the environment as iron 3. So it's in oxidation state of 3, which is a non-soluble form. It does not get solubilized in water at the iron 3 form. But once if you cut off the oxygen supply, and you say if you put a big liner, now the liner acts as an impervious layer. So this is your this liner system is there, so that's your impervious layer. So if just assume that this is the liner, just a part of the liner. Earlier we had some oxygen getting into the system. Now when we put this liner, this oxygen supply got cut off because of impervious layer. Now the oxygen supply is cut off, so what will happen? It will for the organic degradation, if you remember from your biogeochemistry or any chemistry that you have done, we have for organics oxidation we need electron acceptors. So the oxygen acts as an electron acceptor. So once the oxygen is used up, the other is nitrate, and after nitrate it's iron and manganese, then the sulfate. So iron, if the iron is there in the soil in the subsurface, what happens is iron with oxidation state of 3, when it accepts an electron, goes to oxidation state of 2, and this Fe+2 is soluble, so it starts showing up in the groundwater. So although it has nothing to do with leachate or but it's the condition made because of the liner system becoming impervious and no exchange of oxygen, no dissolved oxygen percolating through the rainwater because of the liner, and so it's the conditions created because of that is leading to iron 3 going to iron 2 and the iron 2 showing up in the groundwater. So when you pump the groundwater out, you see a lot of red water, because as soon as the iron 2 is soluble, but as soon as the iron 2 comes in contact with iron 3, when you pump it out, it comes in contact with oxygen when you pump it out, iron 2 gets converted to iron 3, because that's the more favorable condition. So when it goes to iron 3, immediately it will precipitate out. So you will see lots of red things in the water. So that's your iron coming out. So you may have seen that if you have high iron content in your area and you use groundwater wells for your regular water consumption, you take some water out and then you put it in a bucket. Later on you may see some iron traces in there as well, because this iron is precipitating out. Iron 2 is getting converted to iron 3. So that's the basic chemistry happening behind it. So that may cause it. So since it is caused by the landfill, many times the landfills are told that you need to clean it up, although it has nothing to do with the leachate, it has nothing to do with the municipal solid waste, it is just to do with the changes in the hydrogeology condition of the site, which happened because of the liner system. And so then it becomes liable for that landfill to clean it up, to come up with a system to have like groundwater iron contamination has to be removed. I'm just giving you one example, but there could be other examples out there where things at the reducing condition becomes more mobile and then they travel and contaminate the groundwater. So and then we have to monitor it annual or semi-annual. That's the groundwater monitoring has to done every 6 months or every year. Initially it is done in more quick interval, but then if we don't see any pollutants, we don't have to do it in quick interval. As a regulator, as a CPCB, SPCB folk can make that decision. And but if the pollutants are detected, more frequent monitoring must be undertaken. So if there is and then if the contamination is found, we have to take action. So action has to be taken in terms of cleaning it up. We have to clean up the contaminated water which has happened. So and then the cap system, we talked about we talked about the liner system. Now we have the cap system. Cap system is on the top. So if you look at the cross section of the landfill, we had let's see. So if you have the cross section of the landfill is something like this. We have this top cover, and then we have the side slope. So, this is at the bottom we had this leachate liner system and the leachate collection system. So, once the landfill, and then we have the side slope going on as we go up the landfill, we have the side slope coming up, and we use anchor trenches over here, anchor trenches over here. So, sometimes actually if the civil construction job has to be done very, very carefully, otherwise you may have a scenario where this liner does not really meet very well, and then in that case you may have intrusion of water coming inside the landfill. So, but once you have this, you will go like that, and then again on top this cover is separate. So, you have to have some sort of connection here and here. So, at the end and on top of this, and also on top of this side, top here and top here, we have to have a design, the cap system design. So, it is designed to keep the water out and instead of keeping leachate in. So, we don't want any water percolating through. So, we try to design a system in such a way so that this water should not come in. So, we should not have intrusion of water coming in there. So, that's the important point in terms of the cap system design. So, in terms of so what you do after the landfill has closed, says you have to have a post closure care for 30 years, but after 30 years, and even during the 30 years, if there is what you can do, you can if possible, you can convert it to golf course, you can convert it to a park, and even there is a concept of landfill mining now, where you go and do the mining of the landfill, especially for some of the raw materials for which now finding them is very difficult in the natural mines that we out there. We know that we have mined a lot of those materials in the past, and we have used it into different products, and then we just dump it into these landfills in the past because we didn't have any technology. We didn't have any technology to recycle those. So, at that particular time, to recover those materials from that at that particular time. So, we just dumped it into those landfill. So, now since we have the technology out there, there is a concept of landfill mining, where you go and mine the landfill, try to find those material which could potentially be recycled, which could potentially be used as a construction material, and then you can use it in those fashion. So, that is a big area actually of research and work going on in the world globally today, and in the area of landfill mining. So, if you Google the term in landfill mining, you will find several projects happening around the globe on that particular topic. So, with that, let's kind of stop at that particular video, because we will, in the next video, I want to do some math problem. So, it will take some, I would rather start it in the next video, because we are kind of close to our 30-minute duration here. So, let's so what we have covered in this video, we started with the bioreactor landfill. We talked about the concept of bioreactor, whether rather than operating landfill as a treatment unit, how to operate it as a containment unit. Then we also talked about the landfill operation in general, the concept of tipping fee, why tipping fee is important, and you need money to operate the landfill during its operational time and also during the 30 years post closure period. So, you need to have a pool of money for that. And then we also talked about groundwater monitoring system. We talked about in terms of how this landfill is like day-to-day operation of the landfill, compaction of garbage, daily cover. So, all those concepts were covered in this particular module. And then in the next module, I will give you a very simple calculation of some math calculation, and towards the end of the course we will have few maths video uploaded as well, which will help you, especially those of you who are preparing for exam, who will take the exam, will do some solved examples. So, don't worry. There are a lot of solved examples done as part of the course, as part of the slides, but at the same time we will do some extra solved examples which will help you prepare for the exam. So, that's the TAs will come in and they will do that recording for us. So, that's pretty much it for this particular video, and I look forward to doing that math together in the next video. Thank you.